Today we shall see the application of superposition theorem in electrical circuits. Superposition theorem is also one of the fundamental theorems that is used for solving certain problems in electrical engineering. Now, as you are aware that those students who are having this course of basic electrical engineering, they come across many times this type of theorem, superposition theorem. At this stage, I just request all the viewers to go through my earlier video lecture on Kirchhoff's laws, because for this superposition theorem also, while we are solving any such problem with the help of superposition theorem, then we need such basic knowledge as the reduction of circuit as and when required using series, parallel, star delta combinations. Also we also need to distribute the currents in various loops, to identify the loops first, to distribute the currents, to write the loop equations using Kirchhoff's first and second law. So all that knowledge we must have before we consider the superposition theorem. So my sincere advice or suggestion to all the viewers, that those who are still not aware of these facts, the series parallel combinations, star delta connections, or the identification of loops or meshes, then distribution of currents, then writing the equations and the solution of the equations. So please see that lecture. Well, now we shall start with the superposition theorem. Let us not waste much time in this discussion. Only the necessary things I will tell you at the right stages. Why I am telling that? I will tell you at this stage that if you comparatively see the time taken for solving the same problem with Kirchhoff's laws, Thevenin's theorem and superposition theorem, you will immediately find that the superposition theorem takes somewhat longer time to solve the problem. However, we must know the principle of superposition. So we should not avoid studying this theorem only because that is taking a larger time. Okay, so we move to the theorem. Now see, what is the principle of superposition? First thing is that superposition theorem is applied only to the circuits in which there are two or more voltage sources. Means it cannot be applied to a circuit having only one power source, maybe current source or voltage source. So it must have two or more power sources. Maybe both are voltage sources, both are current sources, or say some power sources, some current sources. So not exactly two or more means 2, 3, 4, 5, any number. Okay, so that is the first thing, that superposition theorem can be applied only to such circuits where the number of power sources is 2 or more. Now see our circuit that we have chosen for understanding or application, for understanding the application of superposition theorem, that we have here 3 power sources and all those are the voltage sources. Now why this problem is taken? Again I say that in all the earlier lectures, the lecture on Kirchhoff's law or my lecture on Thevenin's theorem, we have taken the same problem. The reason is that once we arrive at the solution at the end, then we can just very easily cross-check whether our answer is correct or not, because we have already solved this problem using Kirchhoff's law also in earlier lecture and also using Thevenin's theorem in some other lecture. Okay, so let us just maintain the same problem for understanding the application of the superposition theorem. Now see, we have 3 different power sources. Here they are the voltage sources. This is a 20 volt source acting here, 8 volt source acting here, and 4 volt source acting here. Okay, now what is the central idea of superposition theorem is that whatever is your problem, now see our problem statement is written here. Find the current in 8 ohm resistor using superposition theorem. So our problem statement is fixed. Let us just mark these terminals or end points of this resistance with A and B. Okay, so that will be our just first starting step. So we want to find out the current in this 8 ohm resistor. That is our problem statement. And let us just mark the end points of the resistor with convenient letters A, B, X, Y, Mn or whatsoever. Okay. Now see, our problem is this. We have 3 sources acting in the circuit. The central idea of superposition theorem is that you have to consider only one power source acting at a time. You have to consider only one power source acting at a time, means as if the other sources are not acting there that time, and then just find the single effect or individual effect of that power source on this resistance. That means, for example, if we consider that only this 20 volt power source is acting, then this 8 volt source or 4 volt source are not acting at all. They are not there in the circuit. They are not active. That is what we are assuming. Okay. So that is first thing. Now secondly, we have three sources. So we have to do this procedure 3 times. So what we will do initially, we will consider any one power source. Now see, 3 are there. So out of 3, we will consider any one, say a 20 volt source. That time we will imagine that the 8 volt and 4 volt sources are not at all acting. They are just passive. They are not active. Then we will find out the current flowing through this 8 ohm resistor. So what we will record at the end of this procedure, that we will record what would be the current flowing through this 8 ohm resistor only due to action of this 20 volt source, and also we will record or note down the direction of this current, means whether the current was flowing from A to B or B to A. Okay, so that will be our say first result. Now second step, we will move to this source now. So we will now imagine next that only this 8 volt source is acting, but that time this 20 volt source is passive now, it is not acting, and also this 4 volt source is passive, it is not acting. Again what we will do? Again we will find out the current in this 8 ohm resistor and also mention or just record or just write the direction whether from A to B or B to A. And as a third step, what we will do? We will now consider only 4 volt source acting. So we will imagine this 20 volt and 8 volt are not at all there, they are passive. Again we will do some procedure, and we will find out the current in this 8 ohm resistor and also mention its direction whether from A to B or B to A. So in short, whatever is the number of sources, we have to do the procedure as many times, okay, or equal times. So 3 sources, so 3 times we have to solve the circuit, but the aim every time will be to find the direction and magnitude of current in this 8 ohm resistor. Okay, so let us proceed now. So that's why this solution with superposition theorem somewhat larger or more time, because you have to do the current distribution, then write the loop equations, solve them, and finally find the current in that given resistor. But you have to do it many times because your source numbers can be any number. Number of sources can be anything, any large number. Okay, but still let us understand the principle of superposition. So let us start from say this first source, 20 volt source. Now let us imagine that only this source is acting, and whereas 8 volt and 4 volt are not acting in the circuit. So I will just write in the corner here that when only 20 volt source acts alone. So what is our starting point? That we imagine that only 20 volt source, this one, is acting alone in the circuit. Now what is to be done after that? Once you imagine that only 20 volt source is acting, and then you have to say that or imagine that these two are not there. Now when we say they are not acting, but we have to do something in the circuit. So what we have to do in the circuit? See here, we have already seen in the earlier lectures that whenever you have to avoid such a source or from the circuit, or whenever you have to imagine that it is not active, then what you have to do? You have to just replace it by its internal resistance. So what will happen here? Again, they have not mentioned any internal resistances in the circuit. So here in the problem statement, they have not mentioned any internal resistance of any of the sources. That means our sources, voltage sources, are ideal here. So ideal voltage sources will have zero internal resistance. That means what we have to do? We have to just replace these voltage sources by their internal resistance, means zero resistance, and zero resistance is just a short circuit. So here we have to just do this one. Just connect these 2 points directly. So source is gone, and since it was not having any internal resistance, it is just a plain short circuit. And the same thing for 4 volt source, that also does not have any internal resistance, so that will also be shorted in the same way. So I will just short it. Okay, so what we are doing in this first step is that we are considering that only 20-volt battery is there and other sources are replaced by their internal resistances. Okay, so now this will be the starting point. Now henceforth, or from this point onwards, you have to just solve this circuit by simple method of Kirchhoff's laws, as we have considered in the earlier lecture. Okay, so what we have to do now? We have to just distribute the currents, then select or say decide how many current variables are there, then decide how many loop equations you want, then select the proper loops properly with our all previous rules, and then write the loop equations, solve them, and finally find the value of current and its direction in this given 8 ohm resistor. So that we will proceed, that we will do, but we will go ahead very fast. So let us just distribute the current. One small suggestion here is that since every time there would be any one battery, now here while starting the current distribution, you can just start from the positive terminal of the battery, because only one battery is there in all the cases. Okay, so just I will say that this current is I1. So we will do it very fast now. So I1 is here, it reaches here, there are two branches. Suppose I say that this current is some current I2. So this current in this branch will be I1 minus I2. Now this I1 minus I2 reaches here. Again there are two branches, and so you have to again imagine one more variable. So let that variable ahead or current here be I3. So what will be current coming down? It will be I1 minus I2 minus I3. Now this I3 will come down, and this I3 will flow through this resistance, this 8 ohm. Then again I3 and I1 minus I2 minus I3 will meet here. This current will be I1 minus I2. Then again this and this will meet, and so this current will be I1. So this will be our simple current distribution. Imagine again, or say, keep in mind that again here I have taken I2, this was I1 minus I2. Somebody may take I3 here. Okay, that is valid, he can do that. The current moving ahead in that case would be I1 minus I2 minus I3. But why I have purposely taken I3 here? Because when we solve the equations, we directly get the value of the variable I3. Otherwise, if we take, say, I3 here, the current here would be I1 minus I2 minus I3. So what will happen after solving the equations? Again, you have to perform this one more calculation. What is I1 minus I2 minus I3? So let us take a variable in this way. So this is the current distribution. Now see, three variables are there, I1, I2, I3. So we need three equations. So we need three loops. As I told earlier, let us have a practice of selecting small meshes, okay, for writing the loop equations. So here I will select this mesh, this one as first. Then from this point down, left and upwards, this, let us say that this is another one. This first one we call as 1, this one we call as 2, and third mesh that we require, that we can take from this point here, here, here and here. Okay, so this would be our loop 3. Now remember again, all those other rules or precautions must be taken while selecting the loops and writing the loop equations. I have told earlier in the lecture of Kirchhoff's laws that you have to select loops in such a manner that all parts of the circuit or all branches must be covered at least once. So selecting such small meshes can cover all our branches. Now see, all these three loops or three meshes cover all the branches or all the components at least once. Okay, now writing the loop equations. So I will just say here that for loop 1, what would be the equation? Let us travel clockwise as our usual practice. So I will just start from here and just write this equation very fast. So first term will be minus 2I1. Then coming down it will be minus 4I2. Then this to this, no component, no question of voltage rise or drop. And this to this, it will be plus 20. So plus 20 equal to 0. Let us make it somewhat shorter, or say make it simpler. If we divide by minus 2 and further take this 20 to other side, we can write the equation as I1 plus 2I2 is equal to 10. This will be your equation 1. Okay. So just check once more, because see, anywhere if we commit any mistake, make any mistake, anywhere, just that of writing wrong figures in next step, or say making any mistake in writing the symbols plus or minus signs, then our entire solution will be wrong later on. So at every step here, while writing the equations or making them simpler, you have to be very cautious about the signs and also the values. Means you have to fully concentrate on what you are writing there. Okay. So again we check, if we divide by -2 and taking the constant 20 to other side, we will get here as I1, here we get as 2I2, and 20 when it goes to other side, -20 divided by -2 will be 10. Now for loop 2. Let us write the equation for loop 2. From this point here, down, left, and again upwards to the original point. So this to this, it will give -4 times I1 minus I2. Remember, y plus y minus everything is explained in the lecture on Kirchhoff's laws. So let us not waste the time in again discussing that y potential rise or y potential drop. So that's why I suggested, before seeing this lecture or before seeing the viewing the lecture on Kirchhoff's this Thevenin's theorem, you have to see the earlier lecture on the Kirchhoff's laws. So here -4 times I1 minus I2. This down will be -2 times, but now the current in this 2 is I1 minus I2 minus I3. Now we come down here, then to left no component, and upwards it will be +4 times I2. Now we have reached to the original point, so it must all be equal to 0. So let us again simplify. Let us see what all, collect the terms. So -4I1, -2I1 is -6I1. Those are the only I1 terms, so -6I1. Then I2 terms, +4I2, +2I2, 6I2, and +4I2 is 10I2. So +10I2. And I3 terms now, this is +2I3. So +2I3 equal to 0. There is no constant term, because we will find that in this loop there is no voltage source. So no constant term comes there. Okay. And again making it simpler, suppose we can divide by 2. So it will be -3I1 plus 5I1 plus 5I2 plus I3. That must be equal to 0. So this would be our equation 2. And then let us move to the third loop. For third loop, I will just make use of this space. Okay. So this equation, somewhere we should write actually, but let it be, I will just scratch it. Okay. So for loop 3 now. So here, for loop 3. So for loop 3, let us write the equation. Our third loop or third mesh is this point, then ahead here, down, left, and upwards. So this to this, it will be -4I3. Then this to this, -8I3. Then left, no component here, so no question of any voltage or drop or rise. And then from this point upwards, it will be, current is opposite, so +2 into I1 minus I2 minus I3. And all this will be equal to 0. Again, no constant term, because in this third mesh also, there is no battery. And just make it simpler, I1 terms, it will be +2I1. I2 terms -2I3, 2I2. Then I3 terms, -4I3, -8I3 is -12I3. And this is again -2I3. So -14I3. Let us check every time. 4, 8, 12. 12 and again 2. So -14I3 must be equal to 0. Further you can simplify by just dividing by 2. So dividing by 2 we will get I1 minus I2 minus 7I3 must be equal to 0. So this will be our equation 3. Okay. So dividing by 2, I1 minus I2 minus 7I3 equal to 0. So we have got 3 equations. Our next job is we have to solve these 3 equations simultaneously and find out the values of I1, I2 and I3. Now let us not waste the time in solving the equations here, because we have to move ahead to the next step. We have to finish it up in the limited time period. Okay. So that's why I will directly tell you, if you solve these 3 equations, finally what we want the value of I3, because I3 was the current, or I3 is the current flowing through this 8 ohm resistor. So finally what we want? Value of I3 and its direction. So the solution for this is, with the first battery of 20 volt, the current through this 8 ohm resistor, this I3, its value is, after solving, so I will just write here, after solving equations 1, 2 and 3, what we get? We get the current in 8 ohm resistor. This is equal to, its value is 10 by 37 ampere. So 10 by 37 ampere. But here it is very important in superposition theorem to record or to mention the direction of current, whether from point A to B or B to A. Otherwise, finally you cannot combine the results. Okay, so that is very important. So magnitude as well as direction, both are important. Here we get the direction as from A to B. Okay, that means what you will find? You will find that after your solution of these 3 equations, you will get magnitude of this I3 as 10 by 37, but you will get a positive answer. Positive answer indicates that this direction which is assumed is true, and then this direction is from A to B. Current moves like this. Okay, so that is the conclusion of that is the effect of the only first battery of 20 volt. So what is the conclusion at this end of the first step? Is that when we consider only 20 volt battery acting in the circuit, and whereas the other batteries are not at all there, then the current flowing in the 8 ohm resistor would be 10 upon 37 ampere, and its direction would be from points A to B. Okay, so that is first conclusion that we record somewhere. Okay, now next step, we don't have only, means we have 3 batteries. Okay, so we have to do it again 2 more times. Again next for that 8 volt battery and next for the 4 volt battery. So let us move to the second step, that what would be the individual effect on this 8 ohm resistor due to the 8 volt battery, that another one which was here. So let us, now we don't want all this circuit and everything, we will just scratch it. Okay, and then we will draw the circuit only for the 8 volt battery. So it will take some time, very fast we do it, this current distribution, etc. We don't want. Now we have finished the first part. We have finished talking about first battery of 20 volt. Now we have to move to the next effect, that what would be the effect of this 8 volt battery. Okay, so all these currents and everything I will just scratch from this diagram. Okay, so we just want this one. Okay, and I will just complete the circuit properly. Now what we want in second step, we want to see effect of only 8 volt battery. Now when we want to see effect of this 8 volt battery which was here at this place, that means we will consider that this 4 volt battery is not there and also this 20 volt battery is not there. So this should go now. Again, no internal resistance for this battery, that's why it must be represented by just a simple short circuit. Okay, but now this 8 volt battery must be here. Okay, so starting point of your second step or next step would be this one. This would be your 8 volt battery, and this is the circuit. So again the original circuit, this will also go from here. So we just want our original circuit, but now in this fashion, that we have now taken only this 8 volt battery, whereas we have removed batteries 20 volt and 4 volt from the circuit. Okay. So this would be our starting point. So here I will write now, when only 8 volt source is acting alone. So our next step is when only 8 volt source is acting alone in the circuit. Okay. Hence, from this point onwards, the procedure is again same. What? To distribute the currents, write loop equations, find out the current variables and see what is the magnitude and direction of current in this 8 ohm resistor. So that will just, we will do it very fast here. Okay. So here, now we have to distribute the currents due to this 8 volt battery. As I told you, let us keep a simple practice that from the battery onwards we start distributing the currents because only one battery is there. So suppose I assume that this is current I1. Although it is not necessary always to do like that. You are free to distribute current from any point, as I told you earlier. Even with this circuit, you can start distribution from any point. It will still give you the same and correct answer. But as we have mentioned earlier, that let us keep a practice of distributing the currents from that battery, because every time there will be one single battery. So I1 is here. Suppose I mention some current I2 flows here. Okay. Now see, this I2 will move through 8 ohm resistors. Means this time, what is the value that is important for us? This I2 value. Because our problem is to find current in 8 ohm resistor every time. So I2 we distribute. So what will be the current going here? See, I1 comes here. I2 moves ahead in this branch. That means current here must be I1 minus I2. Now this I2 comes. It flows through 8 ohm resistor. It also flows through this 4 ohm resistor. Finally, I2 reaches to this point. This current also reaches here. So what will be the current moving towards left here? It will be again I1. Okay. So I1 I have assumed here. I2 is going like this. So I1 minus I2 here. I2 comes to this point and I1 will move ahead. Now here there are two branches when this I1 comes here. So this is one branch, this is other. So anywhere you assume some other variable I3, either here or here. Say let us assume that I3 is here. Again it is your choice. So what will be the current going to the left? It will be I1 minus I3. Remember, the distribution of current is totally on your own choice. Okay. Only the thing is that the current distribution should be proper and correct. Okay. So here I3 goes here, I1 minus I3. This current comes back. Again they meet here and the current will be sum of these two, that is I1, which is already mentioned. So our current distribution is proper now. And what is next thing? Next thing is to identify the loops and write the loop equations. Again, how many variables are there? I1, I2 and I3, 3 variables. So we need 3 equations. Again, as our regular practice, let us select the 3 individual meshes. So I select that this is first, then I select that this is second, and this would be the third. So next job, very fast, we write the loop equations and solve them. So here I write for loop 1. So suppose for loop 1, let us start from this point. This will be our loop. What would be the equation? Plus 2 times I1 minus I3. Okay. Then coming down, it will be minus 4 times I3. Now we come here. We have to move back here. Again, no other component, no voltage source. So this all must be equal to 0. Let us just simplify it. 2I1 minus 2I3 and minus 2I3 and minus 4I3. It would be minus 6I3. So 2I1 minus 6I3, this all must be equal to 0. Further we can simplify it that 2I1 is 6I3. That means I1 is equal to 3I3. So this will be our simplified equation 1. Now for loop 2. For loop 2. So again, what will be the equation for loop 2? Let us start from this point and we have to write the equation for this. What will be this? Plus 4 times I1. Why 4 plus? Because current will be opposite to us. We are traveling like this, but current is opposite. So we reach here. Down also, we are coming down, but I1 minus I2 is going up. So again, plus 4 plus 2 times I1 minus I2. Next, we have reached here. We have to come to left. Now here coming to left, we are jumping from positive plate to negative plate. That means the voltage will drop. It will drop by 8 volts. So minus 8. Then we have reached here. We have to go up. It will be again plus 4 times I3. Plus 4 times I3. And all this must be equal to 0. While we write the equation initially, we have to check all these polarities and all that, whether we are writing it correctly. So again we will check from this to this. Current is opposite. Plus 4 I1. We have written correctly. This to this down. Current is opposite. So plus 2 times I1 minus I2. That is correct. Then this to left. It will be jumping from positive to negative plate. So potential drop. So minus 8. And this to this point again. We are moving upwards. But the current is opposite. That means plus 4 times I3. So let us simplify the I1 terms. 4I1 plus 2I1. That is 6I1. Then I2 terms. Minus 2I2. That is the only I2 term. So minus 2I2. Then minus 8. That we will take to other side. And plus 4I3. Plus 4I3. And this minus 8. To the other side it will be plus 8. Further we can simplify by dividing by 2. So it will be 3I1 minus I2 plus 2I3 equal to 4. Okay. So dividing by 2 here will give us this particular equation. And now we can call this as equation 2. Okay. So for loop 1, this would be the equation. For loop 2, this would be the equation. Again, one more loop or mesh is remaining. So I will just make use of this particular space here. So let us scratch it from the board. Here, it will be for loop 3. So I mention here for loop 3. Our loop 3 or mesh 3 is like this. This point here, here and upwards. So this to this, it will be plus 4I2. So we have reached here. Then down it will be plus 8I2. We have reached here. Here to here, no component, nothing. So no question of voltage drop or rise. And from this point to the original point, see now current is in our direction. So minus 2 times I1 minus I2. So minus 2 times I1 minus I2. And this all equal to 0. And let us simplify it. I1 term minus 2I1. I2 terms, 4I2 plus 8I2 is 12I2, 12I2 and plus this 2I2. So plus 14I2. This all equal to 0. Further you can simplify. It will be 2I1 equal to 14I2. So I1 equal to 7I2. So this will be our equation 3. Okay. So same thing we have repeated. Whatever we have done with first voltage source. Okay. So what is general procedure? That consider any one voltage source or battery source at a time and then find its effect and find the current in the required resistance. Record its magnitude, means value, as well as its direction, and repeat this with the other sources when they are acting alone. Okay. So first we have taken that 20 volt source. Result we had recorded some current of 10 by 37 ampere. What was that value? 10 by 37, and also its direction was recorded as A to B. Now we have repeated the thing with 8 volt battery while removing the 20 volt and 4 volt batteries. So just the individual effect of every power source on that particular resistance. Okay. That is why that word superposition is used. Superposition principally means that you have to see the individual effects of some causes or sources, and then finally you have to superimpose the results. Okay, superimpose the result to find out the final result when they are all acting together. Okay. So second procedure will be this one. We have got three equations. Obviously, what is our next job? Our next job is to solve these three equations simultaneously and find out values of I1, I2, I3. But in which value we are interested here? We are interested in current in 8 ohm resistor. As per our distribution, it is I2. So here in these calculations now we are interested in I2. Without wasting the time on solutions that you can do later on, I will tell you the result of this, means what is the value of I2. So with this source of 8 volt, we get the value of I2. This value of I2, when you solve these three equations, that we get as 6 by 37 ampere. What value we get for I2 here? We get as 6 divided by 37 ampere. And see, you will get a plus value for this I2. With whatever current distribution we have made, you will get a plus value for this I2 and its magnitude is 6 by 37. So what is its meaning? Since it is a plus value that we are getting with this current distribution, that means whatever direction we have assumed for this I2 must be correct. But now see, I2 is not flowing from A to B, it is flowing from B to A. Okay, so what will be the conclusion for the second source or 8 volt source? The conclusion is that a current of 6 by 37 ampere will flow due to 8 volt battery, but it will flow from points B to A. Okay, so just here we make one compilation of our results. What we have got with first battery is our first compilation due to 20 volt source. What was our result? Our result was current was 10 by 37 ampere, but it was from A to B. Because we will need all these results at the end so as to find out the combined effect. And then second thing we have done, the 8 volt source. So due to 8 volt source, see, they are acting alone every time. No? It is their individual effect in the circuit. So when only 20 volt battery was acting, this was the current in 8 ohm resistor and this was the direction. Second thing also we have just calculated and found out the current here, what we had got, 6 by 37 ampere. But this direction was not A to B, this was B to A. So two results we have obtained. And now again repeating the things for the third source. So very fast we will do it in the similar manner. So let us not waste the time into that. And see, I will again restore the things or just scratch this current distribution and all that. And we will just draw a circuit what we want for third step. Okay. So it will be this situation now. See here, our circuit would be, means now which source we want to consider now? Only this remaining or third source, that is 4 volt source. Okay. So this battery will not be there. 20 volt battery will not be there. So we have shorted it. So it will be like this. Then here I will just make it clear. Okay. This we join. Let us make the diagram clear. Okay. Now this 8 volt source is also not there. So this branch shorted. Okay. And only now we have to show the third battery, that is 4 volt battery acting here. Its polarities were like this. Okay, the polarities were like this. And just making the other circuit clear as before. We just mention the or maintain the names of the terminals same as A and B. We have to maintain that, the terminals A and B. Okay. So this will be our starting point for third step. Again now, as we have decided earlier, as a general rule, not as a compulsory rule, that we can start from the positive terminal of the battery. This was, or this is 4 volt. So let us start from positive terminal. Let this be I1 let any current, this or this, be I2. Suppose this is I2. So current here would be I1 minus I2. Now again there is one more branch here. So let us say that this is I3. So the remaining current which flows here would be I1 minus I2 minus I3. Now this current will come like this. It will go ahead, same value, I1 minus I2 minus I3. Now this I1 minus I2 minus I3 will reach here. This I3 adds, the addition will be I1 minus I2, which will move in this direction. So this will be I1 minus I2. Now this I1 minus I2 will reach here. This I2 adds, and what will be the current going ahead here? It will be I1. And the I1 will come down through 8 ohm resistor. And see here, we had started from the same value. So our current distribution is correct. Now here, in this third step, in which value we are more interested? We are interested in value of I1, because as per our current distribution, the current flowing in 8 ohm resistor is this I1. Okay? And as per our distribution, it is from A to B. Let us see now whether we are getting plus value, minus value. Again now we have three variables, I1, I2, I3. So we need three loops or meshes. So again, as usual, we may select this as loop 1, then this as second, loop 2, and this as the third, loop 3. So again, very fast we write the equations for loop 1. I just forgot to change this, okay, because we are now considering the effect of 4 volt battery, okay. So that I should have done earlier, but let it be. So we are considering the effect of only 4 volt source, okay. So for loop 1 is this. Now start from this point, this would be our loop. Our equation will be minus 2 times I1 minus I2 minus I3. Then we come down, it will be plus 4I3. Then we go to left, no component, nothing, so no voltage rise or drop, and here also no voltage rise or drop. So only these two terms will be there, okay, that we have written. And so this all equal to 0. Rearranging or collecting the terms, minus 2I1, then plus 2I2, and this will be minus 2 plus 2I3 plus 4I3. So plus 6I3. This must be equal to 0. Further you can simplify by dividing by say 2 or minus 2, whatever. So if we divide by 2, it will be minus I1 plus I2 plus 3I3 equal to 0. So this would be our equation 1. Now move first to equation 2 or loop 2. Here I write for loop 2. Let us write equation for loop 2. Our loop 2 is this one. So we will travel like this, okay. So this to this, it will be minus 4 times I1 minus I2. Then from this to down, plus 2I2, plus 2I2. Then from this point to left, no component, no voltage drop, no voltage rise. And this to original point, it will be minus 4I3. So minus 4I3 and equal to 0. So writing it minus 4I1 plus 4I2 and plus 2I2 is plus 6I2. Then I3 term is only 1 minus 4I3. Is all equal to 0. So further simplifying, you may divide by 2. So minus 2I1 plus 3I2 plus 3I2 and minus 2I3 equal to 0. This would be our equation 2. So we have written for loop 1, this would be the equation. for loop 2, this would be the equation. One more equation we have to write. So make use of this particular space. So for equation 3, okay, so I will scratch this, okay. So it will be now for loop 3. Our loop 3 is this here, down, left and upwards. From this to this, it will be minus 4 times I1. Then this to this, minus 8 times I1. We have reached here. Now this to this, we are jumping the battery. But we are now jumping the battery because see, we are moving like this, clockwise. Okay. So we are jumping like this. So negative to positive plate. That means it will be a voltage rise. So plus 4. And then from this point upwards, it will be minus 2 times I2. So minus 2 times I2 equal to 0. So it will be minus 4I1 minus 8I1 is minus 12I1. Then minus 2I2. This 4, if we take it to other side, it will be minus 4. Further you can simplify, we can divide by minus 2. So it will be 6I1 plus I2 equal to 2. Okay. So this will be our equation 3. Okay. So we have got all the 3 equations. Equation 1, which I have just now rubbed out from the blackboard. This is equation 2 and this would be equation 3. So again, same procedure that we have to solve the equations. But now in which value we are more interested? We are interested in value of I1 and also its direction. I will tell you what value you will get after solving these 3 equations. You will get a value 11 by 37, but you will get a plus value. So what value you will get for this I1? I1 you will get as 11 by 37 ampere, but you will get a plus value. You will get a plus value after solving these equations. That means whatever direction we had assumed for I1, that is correct. So what is the direction? A to B. Okay. So I1 we have got 11 by 37. So compiling the third result. So I will write here, due to 4 volt battery or 4 volt source, what is the effect? The current that we get is 11 by 37 ampere, but its direction we are getting as A to B. So it is very simple to determine the direction. You have distributed the current in each case in this 8 ohm resistor. Maybe your distribution sometimes is A to B, B to A. If you get plus answer, that means whatever distribution you have shown, that direction is correct. If you get negative answer, that means whatever distribution you have shown, the actual current must be in the opposite direction. So this way you have to compile the results for all the voltage sources when they are acting independently or individually. So here after compiling the results, we had 3 batteries. We have done the procedure 3 times and we have compiled the results. The final job is only to see their final effect when they are acting simultaneously. Okay. So for that, just one more calculation you have to do. That is like this. See, now it is very logical also. It is very logical that if these are the individual results, then when all the batteries are replaced or they are acting in the circuit, what would be the combined effect? That we have to properly add or subtract these results. Okay. Now see, A to B, this current. Okay. Then A to B again this current. And B to A, this middle one. Okay. So in some very simple manner you can do it. Either you do this thing, that A to B all currents we will add. Okay. And then B to A is some value. You just add or subtract properly. Okay. Or otherwise we can do this way. Maintain any one direction. For example, A to B is this value. This is B to A. But if I want it from A to B, I should take it as minus 6 by 37. So let us do it that way, suppose. So we can write here current in 8 ohm resistor from A to B will be how much? Something we assume. Suppose A to B. What would be the total current? You have to just add them algebraically. So A to B first value was 10 by 37. Okay. Now this second value was B to A and 6 by 37. So what would be A to B value? Just negative value. So minus 6 by 37. And then third result is itself again A to B. So no need to change the values. So plus 11 by 37. So plus 11 by 37. And let us see what we get here. 37, 10 minus 6 plus 11. So what we get? 10 plus 11 is 21. 21 minus 6 is 15. So you get 15 by 37 ampere. And you will find that it comes plus. It comes plus means this is correct. Suppose at this stage you have written here A to B, but if you would have got the negative answer here, that means the actual current must be from B to A. So this way you have to compile the results only. Otherwise, one more thing, you can add all the currents A to B, that will be some value. Then you have this current B to A, you subtract and accordingly find out what would be the final magnitude and final direction. Okay, that means current in 8 ohm resistor from A to B will be this value. Since we have got plus value, that means current is truly from points A to B. Now at this stage you can check the answer of this particular problem. In earlier lectures also we have solved this with Kirchhoff's laws also. We have solved this with Thevenin's theorem also. You will find that the same answer we have got for this particular problem. So this is in general the method or procedure of solving a problem with the help of superposition theorem. Of course, as I have mentioned that since we have to do it multiple times, the same similar procedures multiple times, it is somewhat time consuming. But if we have a proper mastery in distributing the currents and writing equations and writing loop equations and solving them very fast, then you can cut short the time. Now at this stage I have to tell you one thing. Plainly we have taken the same circuit. Suppose in this case we have not talked about any possibility of circuit reduction. I will tell you about that, because that may also cut short our time required for the solution. For example, now this battery, 4-volt battery was acting. Now see, this was your circuit and you have distributed the various branch currents and you got 3 loops, that's why 3 variables, that's why 3 equations, and then you have time to solve these 3 equations was more. Time required to solve these 3 equations was more. You can cut short this time. How? Suppose this 4-volt battery was here. Your aim in this third step was to find current in only 8 ohm resistor. Now you can reduce the circuit from other end. There is a possibility here. For example, what was your circuit? Just let us redraw it. Tips for making your time shorter and shorter for arriving at the solution. Okay. So you have to take a full benefit of the techniques that we have learned. Series parallel conversions or star delta conversions, and also other things or these things which are helpful in reducing the networks. You can take a big help of those particular techniques and you have to try. After you start every step, you have to first see whether we can reduce the circuit and then do the current distribution. For example, when it was only first battery acting, okay, this was the circuit that I will draw fast. This was the circuit that was involved. Okay. Now see, just putting the values, this was 2 2 ohm, 4 ohm, 4 ohm, and this was 4, 2, 8, this was 20 volt, 8 volt, 4 volt. This was our given circuit, and we want the current flowing through this 8 ohm resistor. Okay, that was our problem. Now see what we did in first step. In first step, we considered only this 20 volt battery, whereas we replaced the other batteries with their internal resistances. That means in this problem, we had shorted them. So this was our circuit. This was our starting point for 20 volt battery. Okay. Now see, you want to find current in 8 ohm resistor. You are now permitted to reduce the circuit with your own methods, or say with your own will. Okay. But anyway, you do not touch this 8 ohm. Means you maintain the points A and B, and you protect your resistance in question. Okay. So without disturbing this branch A and B, you can reduce the circuit with various network reduction techniques. Clear observation, or say observation of this circuit, will tell us that we can convert. This is a delta. See here, this is a delta. This is one resistor of delta. This is another one, and this is third one. Because these points are clearly joined together, it is a short circuit. So what will be its equivalent star? Its equivalent star would be like this. One resistor from this point, then one from this, and then the third one of star would be this. Okay. So the delta created by this and this, these three resistances would be this. So star would be this. Okay. Now we know how to find the equivalent values of a star. This value would be 4 into 4, 16. 16 divided by sum total. 4 plus 4 is 8. 8 by 2, 8 plus 2 is 10. So 16 by 10 is 8 by 5. Now this 4 2s are 8. 8 by 10 is 4 by 5. And this would be 8 by 10 again. So 4 by 5. And once you convert this delta into star, your circuit would be just this one. This resistance will go. Then this resistance will go. And this will also be eliminated. So this would be the circuit that is remaining after the conversion. Now you will find that if you rearrange it properly, for example, further what would be the case? This and this would be in series. This and this would be in series. So you can write just one single resistance for these two. Similarly, you can write one single resistance for these two. And so your circuit finally would take this particular shape. You can even write it like this. So finally, after reduction, your circuit will be like this. This was 8 by 5. This was 4 by 5 something. And this was also 4 by 5. So after the conversion of central delta into equivalent star, the circuit reduces to this particular type. And now these two are in series. So you can write one resistance for these two. What would be that value? 18 by 5 here. So instead of these two, it would be 18 by 5. Addition of these two, 24 by 5. You can just represent with one single resistor, 24 by 5. And here it is 4 by 5. See, now it is the same circuit, just we have made use of the network reduction techniques like star delta, delta star conversions. And now see, we have not touched this particular branch. We have kept it intact. That is what we have to keep in mind always. Because this is our target resistance. We want to find out current flowing through this. So this should not go from the circuit. We have to maintain it. So without touching this given branch, you do whatever you want in the circuit for reducing it. Okay? And now see, if you distribute the currents now, if we distribute the currents, you will find that there are only two meshes, you will get only two current variables. So you have to distribute current in this, like this, I1 here, say I2 here, then I1 minus I2 here, and then you select these two loops, loop 1 and loop 2. Because your variables are only 2, you get these two meshes or two loops, you write the equations, solve them, and finally in which value we are interested? In this I2, because in this case this I2 flows here. Okay? So this is one way. And see, maybe sometimes it is not possible to reduce a circuit for some battery, but maybe sometimes it is possible, quite possible, to reduce a circuit to a very simpler form. So if we make use of those techniques, then we can use them in each step. But while explaining the theorem from the beginning, I never mentioned about this particular thing, because we should first know that without doing tampering to the circuit anyhow, means just taking the circuit as it is, then how to use the superposition theorem. But once we have a good mastery on solving certain problems like this, then you can make use of any such techniques and make your circuit simpler at some step wherever it is possible. Okay, so this is the case. Also you can imagine that when your 8-volt battery was acting, then the left side you can reduce. That you will find when you do a practice for this type of problem. Okay, so only addition was this. After understanding the procedure of superposition theorem and after finding out the answer like this, with sufficient practice, we are quite able to use our network reduction techniques to make the circuit simpler at some stages. So we have to make use of that. Okay, so in short, this is the procedure. Again, I wish to mention that a lots of practice will be needed for making mastery on this particular type of theorem. Of course, it is a time-consuming one, but this clearly explains the principle of superposition. So those who have seen the earlier videos on Kirchhoff's law or the Thevenin's theorem, they will understand why we have taken the same problem for consideration or for understanding the application of superposition theorem. The reason is that we have now cross-checked the answer, that the answer every time we are getting the same answer and same direction of the current. Okay. So I thank you. Let us meet again for the next interesting lecture. Thank you so much.